Oh yes, you are most welcome once again to my YouTube channel. And here it is still your tutor Peter Ekaja. And today we are now proceeding with type 2 of partial fractions. And that is a particular type with a denominator where we have a quadratic factor. Now you need to first differentiate between a quadratic factor and a linear factor. When you look at this question that I've started with as example 1, the very first factor here in the denominator, x minus 1, is a linear factor. But then our point of interest, or where we're going to introduce a new concept, is where we now have a quadratic factor, which is x squared plus 1. So for x minus 1, which is linear, we shall handle it as we did in the previous tutorial. That means before you look through this, you should have gone through the previous tutorials for you to be well conversant with what we're doing. Now we have an example before us. And they're telling us to express that expression into partial fractions and then find the integral of the same expression with respect to x. So what we do is, first of all, being very keen, ensure the highest power of x in the numerator is less than the highest power of x in the denominator. You know, when you open the bracket in the denominator, you will have the highest power as 3. That means we have power 1 up vis-a-vis power 3 down. And that clearly tells us this is a proper fraction. And therefore, we are free to proceed. So what we do? We begin by saying we let 3x plus 1 divided by x minus 1 into brackets x squared plus 1 equal to. Now the first factor is linear, so we shall just say a out of x minus 1. Now for the quadratic factor, we shall take a form which is going to be bx plus c divided by the quadratic factor, which is x squared plus 1. I've used b and c because I'd already used a. And remember that form up is in the form of an equation of a straight line. So you don't need to forget that. It must be in the form of mx plus c or ax plus b. Now, from this level, we still do the same mathematics we did in the previous tutorial. We look at the LCM of the right-hand side. When you look at it critically, it becomes the same as the denominator of the left-hand side, and therefore they cancel out. Meaning, we shall end up with 3x plus 1 is equals to a into brackets. You now get the LCM, which is the product of the two brackets, divided by x minus 1. You remain with x squared plus 1. And then plus bx plus c into brackets. We get the LCM divided by x squared plus 1. That means we remain with x minus 1. Then we are going to use two approaches here to get the constants. One will be cover up, and then at some point we can either equate coefficients or we can substitute values of our choice. So we can go through that and look at what happens. Now, if we begin by looking at the linear factor, which is x minus 1, and equate it to 0, it means we shall be having x equals to 1. So we shall begin by substituting or putting x equals to 1. When you put x equals to 1 on the left-hand side and right-hand side, on the left-hand side we shall have 4. On the right-hand side, the whole of the second term goes to 0 because x minus 1 makes it 0. So now we remain with x squared, which is now 1 squared plus 1, giving us 2. So the final expression becomes 2a. And that means the value of a becomes 2. The value of a becomes 2. The next is we can cover up b by substituting or putting x equals to 0. That will cover up b. That means on the left-hand side, we shall have 1. On the right-hand side, we're going to have a when you put x as 0. When you put x as 0 in this second bracket, in the second term, we shall have b times 0, which is 0. You remain with c, come here. 0 minus 1 is negative 1. So multiply by c, it becomes a minus c. But remember, we have the value of a. So we come back and say it means now 1 is equals to 2 minus c. And when you get the value of c, c definitely becomes 1. So we so far have two values, a and c. So we have the two values. What about the value of b? Two approaches. We can say equating preferably coefficients, equating coefficients of, I can look at the highest, the term of x. The term in x with the highest power would be definitely x squared. So we can say you can equate coefficients of x what? Squared. On the left hand side, we don't have any term with x squared. That means the coefficient is 0. On the right hand side, we have a, if you open that bracket, you will have a, and then plus, when you open the second two brackets, when you expand, but you don't need to do so because you can easily see it here, you will get a b as the other coefficient. That means a plus b equals 0, but we know the value of a. That means I'll say 0 is equals to 2 plus b, and therefore b becomes minus 2. Now, this approach of equating coefficients makes life a little bit easy. But if you don't like it, you can substitute any value of your choice in the above expression, except the two values we have already used, except x equals to 1 and x equals to 0. When you substitute any value of your choice, as long as you can manage the situation, the value of b will remain negative 2. So we can now conclude by simply substituting the value of a, b, and c in our expression, and we shall have expressed it as a partial fraction. So we can now say that 3x plus 1 divided by x minus 1 into brackets x squared plus 1 is actually equal to our a, which we got as 2, divided by x minus 1 plus, supposed to be bx, so it is going to be minus 2x plus c, but the value of c is clearly seen as 1, divided by x squared plus 1. So we have expressed our expression as a partial fraction. When it comes to integration, we shall now say therefore integral of 3x plus 1 divided by x minus 1 into brackets x squared plus 1 dx is equals to integral of 2 out of x minus 1 with respect to x plus another integral of negative 2x plus 1 divided by x squared plus 1 with respect to x. Now when it comes to this second integral, this integral here, we are going to do some small splitting a bit. We'll do some small mathematics there a bit. So we shall now rewrite the same step as integral of 2 out of x minus 1 with respect to x plus, or we can even say minus by the way, because I see negative 2x, so I can say minus integral of 2x divided by x squared plus 1. I'm now separating. In other words, this expression that we have here, the whole of this expression here, is just as good as saying negative 2x out of x squared plus 1. That's why I'm integrating it alone, and then plus another integral of 1 out of x squared plus 1. What I mean is we have taken this as negative 2x out of x squared plus 1 plus 1 over x squared plus 1. So I have decided to treat them as individual integrals for purposes of simplicity. So finally the answer comes to 2 natural log of x minus 1. We integrate this, we shall use change of variables. That means our answer is going to be a natural log of x squared plus 1. Why do I say so? Because when you differentiate the denominator, you actually get the numerator. And then 1 over x squared plus 1 dx, we integrate it using tan substitution. And that gives us tan inverse. It gives us tan inverse of x. So at the end of the day, that becomes our answer for the integral of 3x plus 1 divided by x minus 1 into brackets x squared plus 1 with respect to x. As simple as this. So this is what we do when we are dealing with type 2 of partial fractions, and in particular a denominator containing a quadratic factor. Now I want to encourage you that before you leave this video, you subscribe, turn on the notification button so that next time when I post the other examples for this video, you will be notified so that you don't miss out. You keep following us and then you'll become perfect in the mathematics. Please, you can as well subscribe and then share with friends out there. Let the innocent uh, children out there benefit from this mathematics. I will now add on more clarification in my next tutorial where I'll add example 2 and example 3. But this gives us a nice introduction to what we're supposed to be doing. Thank you so much. See you in the next tutorial.